Okay, so we are working on working with strings and built-in functions in VBA and Excel. Next time we get together, we're going to talk about creating our own functions, but we're going to get used to working with some functions that are, kind of currently built in. So go ahead and download faculty.xlsm and open that up, and that's what we're going to do. So in the process of looking at some of these different functions, we're going to start off just by parsing through the faculty name. We want to split this into a first name and a last name. So let's go ahead and begin kind of as an in-class exercise. Get faculty. Oh, here, this is the part that's getting the faculty. Yeah, let's not use that code. That must be in this workbook. Insert a module. Nope. I want to view my existing media project explorer. All right, here's module 1. So it looks like, yeah, I am just using a web query to pull this data in here. So I must have done this before they put that. Well, actually, all I was getting was the first name and the last name, so I'm not even getting the stuff that they are protecting from the crawlers. All right, let's make another subprocedure. Parse faculty data. All right, in-class exercise, and I'll do this as well up here, but just write a loop that will go through and print to the immediate window the names of all the faculty. So we've done this a couple times in class. Control home. And it should just print off whatever's in column B, rows 1 through wherever the data ends. 298. So, you want me to get you started, or you think you're ready to tackle a task like that? A loop that will just print off the faculty names. I hear a lot of kind of stunned silence here for a moment. How many of you are saying, I could totally do this? How many of you are saying, I sure would like you to hold my hand just a little bit longer, Professor Allen? That's figuratively, of course. Okay, a lot of folks aren't voting. Is that because you're checking email or whatever? All right, I'll go ahead and I'll talk us through it. Talk us through it again. So, let's go ahead and get ourselves a reference for our sheet. So dim S as a worksheet. Let's set S equal to the worksheet we're interested in. So what's the name of the worksheet here? It's called list. Is it called list? I have two. I have one called faculty. Hold on a second. Oh, this is like the web query. Okay, yeah. So list is where I want to be working. Set S equal to worksheet, my list. Set S equal to worksheet. Let's declare a variable to keep track of our row. Dim row as a long integer. We'll start row off out at number 2. ROW. And we will do until s.cells row column number 1 dot value is equal to a 0-length string. Column 2 or column 1 will do. So the question is, should we be looking at column 2? And all we're doing right now is we're deciding when to stop. We're not talking about what we're printing yet. And so when given the choice between an identifier and any other data, I prefer to have the identifier because it's much less likelihood that will be blank. And so I like that. So loop. In here, I'm going to increment row. And I'll put a do events. So when I say I would expect you to be able to do a loop like this at kind of this point in your VBA career, that's not necessarily pulling it all out of your brain from scratch. But to be able to say, oh, we've done this before. Let me see if I can find it, change the example that we had before to be able to do this. But here we are. Let's go ahead and do a debug.print. And we'll go ahead and print what's in column 2. And that should do it. Macros are disabled. Well, it sounds like I need to save and close, or maybe I just haven't enabled them. So let me save and close this and reopen, making sure that I enable the macros. I'm going to save this, don't save it. Enable content. I probably just didn't hit enable content before. Go back to that code. I'll execute it. There we go. And so we scroll off the names of the faculty members up here. So that's just the background. So we've got a construct now in place that will allow us to loop across all of the, or iterate across all the data that we're wanting to work with. Any questions? Anyone still working on getting this loop up and going? Need another minute or two? Do you need help, or you just need a little? Just go ahead. All right. So the whole idea here is that the VBA language has both statements, like the if statement. You know, it's just, this is kind of a structure. The select case statement, it's a structure that allows us to do something, but also built in as part of the language are a set of functions. So what's the primary difference between a VBA statement, like trying to think of a really good statement in VBA that we've seen so far that's comparable to what I'm going to talk about, and I can't think of one. Well, the problem, so debug.print was the one that came to mind immediately, but debug.print is not a part of the VBA language. So there's an object in Excel called the debug object, and it has a method called print. And so we have access to that object, but it's not a foundational part of the language. So maybe one good way to think of it is like the message box. So here's one that we've seen, MSGBOX, and it's not such a good example for other reasons, but we'll just talk about it here. Hello, H-E-L-L-O, world, W-O-R-L-D. So if I execute this, then it just puts up a message box with whatever text I specified in there, and that's what it does. So a statement just does something in VBA. Now a function is a little bit more involved. Not a whole lot more involved, but it is just a little tiny bit more involved. So any thoughts on what's the difference between a statement and a function? I'll define a statement. A statement just does something. A function does something, and there's a little bit more to it. Want to take a shot at it? A function does something the same way a VBA statement does, but when the function is done doing whatever it does, it sends a value back to where it was called from. So just like in Excel, when you say, oh, I'm going to use a particular function, use the net present value function, the NPV function. You put a bunch of values into it, it goes and does something with those values, and it sends you something back. That's what functions do, always in programming lingo, is that a function does something and then gives you back a result. Functions return results. And so we need to make some provision to receive what the value is from that result. So let's go ahead and just take a look at one of these functions. There's one called inString. It shows the position of one string inside of another string. So I might be interested to know where the comma is right here in this string. So I'm going to simplify this code as we're looking at it, I'm actually going to bring these characters over into my immediate window, and I'm going to say inString, I-N-S-T-R, I-N-S-T-R, I-N-S-T-R. Now in parentheses, I got to tell it some of the arguments. I got to give it some arguments to go to these parameters. So the first one is, in the string that you're about to look at, where do you want to start? And I want to start at character 1, the very beginning of the string. It then says, what string do you want to look at? In this case, I'm just going to go ahead and put this in as a string literal. I'm just copying that value of the first professor from our, or the first faculty from our set. Close that off. Then it's asking, what do you want to look for inside that string? And this is just going to be a comma. I want to find the comma. This gets a little bit tricky because I'm using a comma now to separate my arguments, but one of my arguments is itself a comma. So, but I'm looking for a comma in this string. And then the last argument here is, well, how do you want to look at this? Do you want to look at this in a case-sensitive way, a case-insensitive way, or is there some other kind of context you want to look at? I'm going to make this case-sensitive for now. That's the default here. That's a binary comparison, so I'm going to just leave that last argument off for now. Now, when I execute this, it's going to say, something's wrong here. And the reason is because a function returns a value, it's actually going to take the whole call to the function and it's going to, you can think of it as replacing the call to the function into the place where the function call was made. So it would be like if by the way, what is this going to return? What will this figure out and return to me? So if I count over 1, 2, 3, 4, 5, 6, it finds that comma in the number 6. It's the number 6 character. And so this would be something akin to like, what it's going to do is it's going to run. It's going to say, I got to figure out what this is. It's going to go figure that out, bring that back, and it's going to like replace the call to the function with its result. It would be like coming onto a line and saying 6. Because after it figures out the 6, it's going to drop it into where the call to the function was. Does it make any sense for me to have a statement in VBA that just says 6? And if I tell VBA to do it, if I hit enter on this line and tell the interpreter 6, what is it going to tell me? I can't do that. I don't even know what you mean by that. And think of it, I mean, if I came up to you and said 6, what would you do? Maybe if you were a betting person, you go bet on horse number 6 or something, if you thought I knew what I was talking about there. It's not an instruction. It's just a value. And so now what I can come up here and I can say print 6. Now I'm doing something with the value with that value. It knows how to print 6. In the same way, it knows how to print the results of this function. And so that's the first step. When I'm using a function, I have to do something with the value that comes back. All right. Now, this next part I'm going to tell you is one that if you understand this right now, your life will be so much easier programming in VBA. This is a place where the folks making the VBA language made a bad choice. They're making thousands and thousands of choices when they're trying to decide how this language is going to be. And this is a choice they made that made sense at the time, but they have come to find out they shouldn't have made this choice. So stick with me for this next part, and if you can grasp it, now is the time. This is not something you want to take notes on and go learn it later. Just learn it with me right now. It turns out that many functions can be used either for their functionness, just we really want to see the value that comes back from the function, or I might only be interested in the byproduct of the function, what the function has to do on the way towards calculating the number that it's sending back. And one of these examples here is the message box. It's actually a function. So let me go ahead and say I want to print the results of this function. Now, here is, if there's something to commit to memory, this is something that you just want to memorize. Now, I'm going to help you understand why it's the way it is. But here it is. If I am going to do something with the result of a function, that's what I'm going to do. I'm trying to print out the result of this function. You got the question mark there. I must put parentheses around the argument list. So if I just try to print this, I think that's going to give me an error. Yeah, it says, we're not quite sure what you mean here. But now I am going to put parentheses around the argument list. That's the values that I'm sending to the function. And now, when I execute that, it's going to do what the message box does. Put up a message box. It's trying to figure out what to return. I'm going to click on OK, and it's going to return a 1. It sent back a 1. What does that even mean? I think it means I clicked on that OK button. I wonder what would happen if I clicked on the X to close it instead. Can I even do that? Still prints a 1. This becomes a lot more interesting if I give it, the second argument here says, which buttons do you want to include? Well, let's just try VB yes, no, cancel. VB yes, no, cancel. So this is a constant that's built in. It's just a number, by the way. VB yes, no, cancel. It's just a named number. I can print that off, and I don't know, it might be 1 itself. It's 3. So that's just, it's just, VB yes, no, cancel is the name for location in memory. It's a constant. It's built into VBA. What's the value that's at that location in memory? 3. So when I send a 3 as the second argument here to the message box, it behaves differently. How does it behave differently? Let me go ahead and just put this code here. Now it's got a different set of buttons. Instead of just a yes, it's got a yes, no, and a cancel. Yes, the yes button returns what? 1. The no button returns 7. Oh no, I'm sorry. The OK button returns 1. The yes button returns 6. No returns 7. Cancel, I think, is 8. It's 2. Never mind. These numbers come back. And so if I'm going to do something with the value that comes back from the function, I've got to put the arguments in parentheses. Well, what happens if I take the question mark off and try to run it? The syntax isn't valid. Why? I'm not doing anything with what comes back from the function. I'm just trying to use it right there. It tries to make itself a statement of its own, and no good. If they were writing this language again today, you know what they would say? Just put parentheses all the time. Don't you think your life would be easier if it was just put parentheses all the time? Yeah, I think my life would definitely be easier because, well, it'd be harder to come up with a good midterm exam because this is a really good midterm exam. Do you really understand this point? It's an important point to remember. Okay, but I'd have a lot fewer questions. That'd be good. All right. So do you want to know why they have the parentheses at all? Here's the reason that you have to have parentheses. Is this argument required? No, that argument's not required. And so I could leave that argument out. In fact, I could come in here and say, instead of saying hello world, I'm going to say hello, and then I'm going to concatenate on the name of the person who's running the code. Ampersand. For right now, let me just go ahead and hard code my name in here. So that will say hello gov, and it'll say yes, no, cancel, which is actually, as long as I say print, which is, kind of normal. Yes, hello gov, yes, no, cancel. That doesn't make any sense at all. I mean, those buttons don't belong there. Have you ever gotten those buttons? It's all the time you see it. Here's the answer. The answer is a yes, no question. And what do you get? OK, cancel. They ask a question that's yes, no, clearly a yes, no question. Could they make a yes, no button? Yes. That would be easy. They give you OK, cancel instead. So this makes about as much sense as we normally see. But now, instead of having this hard-coded in, let me drop another function in here. Before I put it in there, let me run it by itself. So question mark input, INPUT, box, opening parenthesis, enter your name, enter uname, INPUT. So now we're trying to print something. The interpreter says, oh, we got to figure out what this is before we can print it. So it has to do what the input box function does. What does that do? It puts up a little box. It puts the text that I specify there and allows you to type something in. So I say enter your name, Alan. I hit enter, and it then prints Alan. But now, if I take this function right here and replace the name with it, now it's going to say, oh, I got to put up this message box. Uh-oh. Before I can put up the message box, I have to figure out what this is. So it's going to first put up something that says enter your name. Once I take care of that, that value will come right back here to this location, and whatever that returned will get concatenated onto hello, and then it will put that up with a yes, no, cancel button, and it will print a number that corresponds to that number, to that button I chose. So now I'll run this, by pressing enter on the line. It says, what's your name? I say, okay, now it's going to feed that result right back into this portion, and whatever I've typed in there will be concatenated onto hello for the input box. Hello gov, that's great. And so the reason that we have to have parentheses here is that there is another argument here. The input box has an optional argument. I can put a title in right here. And so since there's potentially another argument here for input box, and right after that there's potentially another argument for the message box, if I didn't have these parentheses here, how could we possibly know which function this belongs to? Does this belong to the input box, or does it belong to the message box? And the answer is, without the parentheses, there'd be no way to know. And so when they're making the language, they said simple. When you're calling a function such that it's going to return its value to do something with it, you've got to tell me where the arguments end. And so that's why we have to put the parentheses here, so that the interpreter can figure out, oh, this doesn't belong to input box, it belongs to message box. It's because we can nest functions inside of other functions, or use the result of a function as a value to get sent off to another function, that we have to have the parentheses on. Now, they were saying, well, listen, if we don't really want to do anything with the result, then all of this is a statement. Its value isn't coming back to anywhere. There's no possibility that the result of this is going into something else. There could be no confusion. And so they just said, you don't need parentheses. There's no reason to need parentheses here. So they said, don't put them. And in fact, that will run just fine. It displays this up right here. I'll type in GGGGGGG. And that GGGGG doesn't go anywhere because I'm not doing anything with the resultant value. You ready for one more level of confusion? At this point, how many of you are going, okay, I think I got it? How many of you are going, I hope the TA can do a better job explaining this because I'm not following this at all? No one? Okay, here's one more thing that makes it even more confusing. Let's say I wanted to put up a number here instead of a name. Let me just say I just want to put up 66. Do you think that will work? Could work just fine. 66, that's great. Now let's say I want to do 66 plus 600. Will that work? Yeah, that'll work just fine. Let's suppose I wanted to put parentheses around that, and after I did the addition, I wanted to multiply it by 2. You think that? Multiply by 2. Think that's going to work? That'll work just fine. 1332. Great. Now, let me take off the multiply by 2. You think that'll work? The temptation here is to say you've got parentheses, and you're not allowed to make a function call with parentheses unless you're going to do something with the result. But this works just fine. The reason that it works just fine is it sees these parentheses as the kind of parentheses are just part of the math. If I had that parentheses in here and I put a comma and said I want to put something with a second argument like the title, now all of a sudden these aren't just the parentheses that are these are not math parentheses. There's an argument here in the middle. These are two arguments, and it says you're not allowed to do it. And so, yeah, the rule is if you're doing something with the value that comes back, you put parentheses. Otherwise, you don't. Where this becomes a problem is you might say, well, you know what? I want to do this. Whoops. Will that work? It will work because it sees those parentheses as binding parentheses rather than argument list parentheses. And so if you've come from some other environment, and this is common in other languages, you always put parentheses, and you find yourself putting parentheses even when you don't need them, this will work just fine. You will be absolutely befuddled by why when you do this, it won't work. And the answer is that if you're not doing anything with the return value, don't put the parentheses. It happens to work this way, which is maddening. But that's the language we're working. It's the way it gets parsed. Question?
Well, when we're writing code, when we're not accepting with the end value
So the question is, when we're writing code, when would we ever not do something with a return value? And the answer is message box. There's others, but sometimes you say, you know what? I don't care what the value is. I just got to give some information to the user. I don't care if they press on yes, no, or cancel, or yes or no or close. I don't care. I've given the information. We're done. We're moving on. And so that would be a good example. We're after not what the function returns, but the byproduct. What does the function do on the way to returning something? That's the behavior that we're after. Okay, question here.
So, for example, like assigning the input to a variable, that would be doing no.
Yeah, so the question is, if I'm just assigning the result of the function into a variable, then that's okay. And the answer is yes. Yeah, I don't have to print it out, but yeah, if I say x equals and then call to a function, that function gets evaluated, something gets evaluated to 7, and then the resultant statement is x equals 7. That's okay. That's all right. All right, so now let's go ahead and parse out this faculty name. So I'm trying to find out where's the comma. So in so doing, let me set up another variable for myself here. I'll need something to keep track of the position of the comma. I'll abbreviate that to POS. It is an abbreviation for position, nothing else. And I'll do that as, I can do it with a byte, but I'll do it as an integer. All right, so we're going to print off the whole value, and then let's go ahead and get some work in here. So my position is equal to, in string, looking at that thing that I just printed. So I'll copy that expression. Whoops. The first argument is starting where? Starting at 1. Looking at whatever I have in column 2 of my current row, looking for the comma. Closing the parenthesis. So that's going to return a number somewhere between 0 and the length of the string that I'm looking at. Why would it return 0? What does it mean if it returns 0? It means it didn't find it. Yeah, it means we couldn't find it. That's how it tells you I couldn't find it. Return 0. If it finds it, it'll be the position where it finds it. Well, and it can be multiple. I could look for this. Let's see. Let's look for comma space, not just a comma, but comma space. Now that's 2 characters wide. What numbers are going to return? Still 6. It's going to, from that former example, it's going to return where the substring starts. So you can have multiple characters in here. I'm going to go back just to a comma. Okay, so let me go ahead and maybe I'll move my debug.print a little bit lower after I set up what that position is. And now I'll print the value, comma, and the position. So now as it prints all of these off, it will show me the name and then the position of the comma. That should be, kind of diagnostic. That's good. So I'll run this. And there they are. So might as well just kind of look at the end here since that's what's showing when we're done. So Zimbelman, it says the 10th character. Is that right? I guess it is, but let's just check it. Just look really quickly. There's the first character. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, the comma there is the 10th one. Holy cows, that next one must be wrong. Zabriskie is showing 10 as well, but the comma is way over there. It's over by almost 1/4 of an inch. Is that right or wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Why does it look so off? Because I's aren't nearly as wide as M's. I got 2 I's in this one, 2 M's in that one, and so it just stretches things differently. All right, so now I have a position. What I'd like to do now is use that to figure out what the last name is. So let me go ahead and declare a couple more variables. I've got my position here. Escape. Turn the volume down. Let me dim last name as a string. Let me dim first name as a string. I'm going to go ahead and capitalize my name in both of those. Why do I capitalize those? One, it makes them easier to read, but the main reason is when I go to type this in my code, I'm going to type it in all lowercase. And if I've typed it right, I'll want to see that capitalization pop into it so that I can see, it was recognized. So I've got a position there. So now let's do last name. Last name is equal to, now there's another built-in function that I can use to get the leftmost portion of a string. What's that function called? Yeah, left. Left, L-E-F-T. I give it a string that I'm looking at. In this case, it's going to be that same cell. I give it a number of characters that I want to take. So if the comma is my 10th character, how many characters do I want to take off the left to get the last name? Yeah, 9. So position -1. And so now I will print the last name as well. In fact, let me go ahead and instead of just printing out that last name, I think this is something I actually want to write out to my worksheet. So I will just say column 3 value is going to be equal to last name. So we're still printing off the name and the position, but now I should also be seeing Zimbelman, Zabriskie, Young, Wright, and Worsham showing here into column C. So I'll run that. And we've got the last name showing in just fine. Just want to make sure I don't have any errant spaces. Anytime I'm processing strings, parsing strings, probably a good idea just to look in there and make sure I don't have any spaces before or after, and that looks okay. Okay, any question here? All right, how about pulling off the first name now? Or comment or question? Question is, can I just review inString one more time? So looking at this function right here. Okay, so inString is going to find the position of one string inside of another. That's the, what have I done? That's the origin of the name of the function, inString. I'm going to find where is this string in another string. And so I'm putting that into a variable called position, or short for position. So I call the function inString. The first argument is, where do you want to start looking? Now, these are really short strings. But imagine I had, how long can a string be? Do you remember? 4 gigabytes, right? I could have a whole book in one string variable. And maybe I'm looking for the text that comes right after the word chapter. And so I found chapter, here's chapter 1. So I'm somehow finding where chapter 1 is, where chapter 1 starts. But I want to be able to find where chapter 2 starts. Find the next occurrence of chapter. I don't want to start from the beginning. I'll find chapter 1 again. And so I got to tell it to look after wherever I found the last one. So that's what that first argument is. It says, don't start at the beginning, start somewhere else. But by putting a 1 there, we're saying, yeah, start at the beginning. Then the next argument is what string I'm looking at. And so I'm reading the value out of column 2. So in this case, the very last record here, Zimbelman, Mark. And I'm looking for the position of the comma. This will return a number, in this case 10. We see it printing the 10 right here, because the comma is the 10th character here. Now, what if I started looking at 5? What if I changed this to 5? How would that change what gets returned when it's looking at here at Zabriskie? Let me change it to 6 instead of 5. When I'm looking at Zimbelman, what is that going to return now? What's it going to return now? The answer is it will still return 10. It says it's going to tell me the position of where it finds a comma after the 6th character. Well, it's going to start looking after the 6th character, but it's going to return the position that exists in the string. So let's look up here at David Wood. If I'm telling it to start at 6, what is it going to return? Yeah, so now it says, all right, show the first occurrence of a comma after, starting with the 6th character. 1, 2, let me do it here where you can see a little better. 1, 2, 3, 4, 5, 6. So so it's going to consider everything from the comma over. Does it from the space after the comma over? Does it find a comma here? It does not. And so this would return a 0. Now, at this point, I can't run the code because I'm using that position somewhere else. Down here in my left, I'm using position -1. That's going to say, give me the left, how many characters off that string, off of David Wood? The left, -1 characters. That's going to confuse it. So I'll have to make this correction before I can run this code again. Start at 1. And I guess, yeah, so we've run that code. It already puts the last name in there. Okay. Let's do the first name. So here's where we're putting the last name. Let's put the first name in there. Oops. So I just copied that line because it's really close to what we need. I'm going to put that in column 4. Oh, I guess I need to actually calculate what the last name is, or the first name is. So I'll do that in a separate variable. First name equals, okay. How do I do it? Do I need the left function at all here? No, what do I want? Could use the right function. So the right function, I got to tell it how many characters to take off of the right of the string. So let's talk through it. What would I have to do? Let's look at Mark Zimbelman. How many characters do I need off the right of this string? Let's get a simple answer. 4. I got to get Mark. That's 4. But how do I get to the 4? I know the position of the comma, and you're headed in the right direction, and I know we haven't seen how to do the length of the string, but let me show it to you. There's a function called len. I always think of my oldest cousin. His name is Len. It's spelled differently, but len. He doesn't spell it L-E-N. Maybe he does, for all I know. I think it's really short for something else. L-E-N, just like that. I don't think his middle name is Leonard. I think it's L-E-N-N. I don't know. That's something to Google. He's a composer, of all things. C-O-M-P-O-S-E-R, David and Allen. Oh, I guess that is how he spells it. He spells it just that same way. Now I'll think of him even more. So that's going to give me the length of that string. Now, if I already have the position, I could say the length minus, I'll just write the function here again to calculate that position. We'll just bring it up here. Well, I can't use POS here because this code isn't running. I'm just executing this line here. So the whole thing has to run right here. Yeah. So I'm looking for the position of the comma inside that string. That now gives me 5. Now, how many characters do I want off the end? 4. I want 4, so it's going to be that expression minus 1. There's an easier way to do this. That would do the trick. But let's look at the easier way. So left takes the leftmost characters. Right takes the rightmost characters. Mid takes characters out of the middle. So let's look at, instead of asking for the length of this, let's look for the mid. The mid of Mark Zimbelman, or Zimbelman Mark. And then I'll just tell it where to start. I'll say start counting at the, let's do the 10th character for start. That's what our position is in this case. And so that says, start the 10th character. Let's just say I only want to take 3 characters. Another argument here. Take 3 characters out. And so start with the 10th, taking 3. It's comma space M. If I don't tell it how many characters to take, what does it do? It returns the whole rest of the string. That's nice. Now, I don't really want it to start at 10. What do I want to start it at? 12, 10 plus 2. And so now I just get the first name. Assuming that that comma is always followed by a space, and I think in our data we can rely on that being the case. So now my first name, instead of being left, it will be mid. And we'll look at that same string. Instead of looking at position minus 1, we'll look at position plus 2. and then we will use that first name to drop it into the proper column. By the way, could I do this with one line instead of two? Yeah, instead of putting this into first name and then taking whatever's in first name and putting it here, I could just write this whole line and drop it right here. Do you see it? Just say, do this expression, parse this out to find out what the first name is, and put it where? Put it into that column. But this is just a little bit more readable for us as we're just starting. So if I run this, I should put the first names now into the data there as well. So we have successfully then parsed that string apart. Questions on what we've done here? Go ahead with the question here. Yeah, so the question is, not quite sure why we have a +2 here on the mid. Let's just look at a different example. So did all that work to copy that? And I didn't copy the whole thing. Let's look at the mid, and let me put a longer string in here. Okay, there's some string that I'm looking at, and I just want to pull the name Nephi out of this string. Where do I want to start? Just to pull Nephi out of here, where do I start? What character do I want to start at? I think it's the fourth character. Let's see. 1, 2, 3, 4. That N is the number 4 character. And so I'm going to tell this to start at the fourth character, and N-E-P-H-I. There's 5 characters in Nephi, and so I tell it to bring 5. I'm asking it to take something out of the middle of this string. So here's the string I'm working on, to Nephi serial of olden time. Start at the fourth character, and return 5 characters. This should give me Nephi. So that's the fundamentals of the mid function. Now, if I leave off the second argument, it's still going to start at the fourth character, but I haven't told it when to stop. Where's it going to go? It's going to keep going until the rest of the string. So it's not like it's broken and that's just what happens to happen. It's designed to do that. So I can say start here and don't tell it anything else, and it brings the rest of the string. So it starts with that same N, takes the rest of the string. So what we're doing down here is we're saying we want to take the middle out of whatever name we're looking at. Let's look at Mark Zimbelman here. So when we're processing line 298, the text that we have highlighted here is Mark Zimbelman. What is position, by the way? In this at this point, what's position? Do you remember? It's 10, right? Because if we were to count this up, Zimbelman has 9 characters, and so the comma is the number 10 character. And so POS at this point has a value of 10. So we're saying, listen, I want something out of the middle of this whole name, Zimbelman, comma, Mark. Great. Where do we want to start? Wherever that comma was, 10. But if we start at the comma, what's the first character? It's the comma. We don't want the comma. We don't want the space that we're assuming always comes after the comma. And so we're going to add 2 onto that position. And so it will start at 2. It'll start at 2 characters past that comma. So it will start with the capital M of Mark. So that's how we're getting to that first name. Well, the question is, that's 2 characters including the comma, and the answer is, it is the position, 10, plus 2, so this is just going to be a 12. And so where do we start? 12th character. First, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the 12th character, the M. Question in the back. Do we need this debug.print line, the one that we have right here? And, oops, escape. And the answer is, well, if you want to print the results in the immediate window, yes. But if all you're trying to do is get this data to go onto the worksheet just to split these out, then the answer is no, you don't need it. I mean, that's just putting it up to the window. We're processing just fine without it. Other questions? So mid, left, right, and in string go a long way towards parsing string data. So let's talk about some others, but go ahead with a question here.
Is there a way to search for letters?
Is there a way to search for capital letters? So you want to just find the first capital letter. You're saying, well, there may not be a comma here. Maybe what we've got is we want to just look for the capital letter. What do you think? Is that possible? The answer is yes, it's possible. But I think your real question is there some easy way to do that with a function that's built for that? And the answer is no. We could write our own function to do that, which is the topic of our next class, is writing our own functions. So today we're getting familiar with some of the built-in functions with Excel. And these that we've talked about here, in string, mid, left, right, these are all fundamental parts of the language. How many statements and functions are there in the whole VBA language? There's about 100. There's not that many. Most of what we do, we're manipulating methods of objects. So objects, someone else has written an object, like the range object has all kinds of methods and properties with it. That's great, but that's not part of the VBA language. But these that we're talking about here, these are a fundamental part of the VBA language. Okay, let's look at a couple of others that, let's suppose that there was some rule that was declared that anybody named David has to have their name changed to Dave. We got to show David's got to be Dave. So let's go ahead and do another column here. We'll call this the new name. And we'll set up the new name to be equal just to, well, in this case, we'll do it. So wouldn't it be nice if we could just say, look at this string, find every occurrence of David, and replace it with Dave? That would be nice. There's a function for that called replace. R-E-P-L-A-C-E. Replace says, look at some string, find in that string every occurrence of some other string, and replace it with whatever we're looking for. So in this case, what am I looking in? I'm looking in that same cell. So look at the original name, look for, and we now start to get commas and quotes galore here. So I'm going to put in the syntax before I think about it. In fact, whenever I get to the replace function, I always do this. I put in the first value, and then I say a couple of quotes, comma, a couple of quotes, and then close my parenthesis off. So I've got the syntax in here, and now I've got my next two arguments ready to go. I want to look for every occurrence of David and replace it with Dave. Now, in fact, there are a couple other arguments here. The next argument is, where do you want to start? You don't have, like the in string, you don't have to start at the beginning. So you can tell it where to start. You can tell it how many do you want to change. Do you want to change just one occurrence? Do you want to change two occurrences, the next two occurrences? Or do you want to do them all? If I leave it blank, it's all. Or I can tell it, do I want this to be case sensitive or not? We'll come back to that argument here in just a minute. For now, let's just leave it with those three arguments, what I'm looking at, what I'm looking for, and what I want to replace it with. Good question. So the question is, shouldn't we be doing this before that? And the answer is, what I'm trying to do here is I still want to pull off would David here, but now in the next column over, I'm going to print just whatever was here, last name, comma, but instead of whenever it's David, I want it to say Dave. So depending on what we're trying to accomplish, yeah, maybe we would want to do it earlier. But in this case, all I'm saying is, no, let's just, I'm going to put that whole last name, comma, first name back here, but I've replaced Dave with David. Let me run this, and I'll take your question. And I've never put it out yet. So there's my new name. Let me go ahead and write this into, was that your comment? Oh, I'm still not there yet. Stand by. So let me write into column 5, and this will be the new name. And so now here's Dave Wood. It hasn't had any effect on Ryan Wood because the word Dave is not in there at all. It found every single occurrence of David. How many were there? None. On that particular line. But everywhere there was a David, it's here. Do we have someone named Davidson? Let's just look up here. Do we have a Davidson? If we've got someone here called Davidson, it will have changed him to Daveson. I just don't know if we have any faculty named Davidson. Pity. But we could change Morgan Cummings to Morgan Davidson. Hope Morgan's not offended by this. Oh, good. Oh, actually, yeah, that would be a problem for these, but this would still work okay because this is independent of the comma. But you're right, I left the comma out there, so let's put that comma back in. Run this code again. And now we've converted Davidson here just to Daveson. Now there's a question here in the front row. So the question is, hey, does this, when we say this replace, is it not actually replacing what happens in column B? And the answer is, yeah, this is a really important concept that you understand about functions. And that is that when I make this call to replace, this value that I'm putting in here, this is an argument that I'm sending to the function. I am just sending this string of characters to the function. I'm also sending a couple of other strings to the function. It then takes that input. It does not change any of the input. It just takes that as input and says, okay, I'm now going to operate on what you've sent me, and I'm going to send you back another value. And so functions in VBA never operate on the arguments that have been sent into them. Now, as it turns out, when we write our own functions, we could make it do that. It's almost always a mistake when you do that. But it's possible, it's actually pretty easy to do. But yeah, typically you say, send these values in, don't change what I've sent there, and then send back a value that I'll use to keep track of what I was after. So that's the replace function. Questions? What other built-in functions does the book talk about? A whole set of string functions. A couple of others that we'll just kind of go over quickly. There's one to switch to uppercase and to lowercase. So ucase is the uppercase version. That will just give me back the uppercase version of whatever I send to it. It takes a single argument. There's a corresponding L case. There is no corresponding P case, like to put something into proper case. But any of you familiar enough with Excel to know what the function is there's a function called proper. And I don't think we've ever seen this before, but in addition to having access to the functions that are built into VBA, you can call any Excel function you want from VBA as well if it's built into Excel. Here's how you do it. What I'm going to say is worksheet function, worksheet, F-U-N-C-T-I-O-N, dot. And then here's all the functions I want. What was it called? Proper? P-R, I guess I could spell it out. There it is, proper. And I'm going to send it this all uppercase version, and it should return the proper case version of that name. It's not so sophisticated. All it's really doing is capitalizing every first word. So maybe that's what proper case means. But if you had like the Duke of Earl here, the of would be capitalized as well when you wouldn't expect it normally to be capitalized. Are worksheet functions slow? Are worksheet functions slow? That's a relative question. So let's give something to reference to. Are worksheets functions slower than built-in function, part of the language? The answer is yes. How much slower? It'll be measured in nanoseconds, depending on your computer. Measured in nanoseconds. So if you're doing, a few hundred in your program, not a big deal. If you're doing a few 100,000, it would probably be a noticeable difference. In fact, because they're slower, if there is an analog to a function that's an Excel function, if there's an analog as a VBA function, you can't call the Excel function. So how do you do uppercase? What's the uppercase function in Excel? It's called upper, I think. We could go to a cell and check that. So let's try to find upper here. Worksheet function dot, what have I done? I spelled that wrong somewhere? There we go. Dot upper. Here's my U's. U, N, there's only 3. Well, there's only 3 right there. I get Unichar, Unicode, and US dollar. There's no U case, there's no upper. Why? Because in VBA, there's a U case. So, wouldn't it be nice here if it actually would show the U case, or upper and says, by the way, you can't use this, use U case instead? Sorry. It doesn't. It just, there is no upper function part of the worksheet functions object. Realize that what this is an object. Somebody somewhere built an object called worksheet function. And it has all these functions built into it, and they are invoking the standard functionality as part of Excel, but they had to write that object. And in so doing, they said, we're not going to duplicate the function that's part of a VBA. And the reason is, it's faster to use a native function. Okay. I did want to talk about that matching case, whether it was case sensitive. So let me come back down here to this new name, and instead of looking for David uppercase, I'm looking for David lowercase. So now I'll go ahead and run this, and Davidson still persists because it doesn't find David because it's case sensitive. The default is for case sensitive comparison. Well, that's one of my arguments that I can specify out here. So I'll come out here and I will say, you know what? I want the default value for where you start. I want the default value for how many to take, but where to start, how many to do. I was kind of expecting to see, oh, here we go. And so now I have here, I'll do a text comparison. Both in the in-string function and the replace function have this argument. So I'll put a text comparison here at the end. I've got 3 commas here because I'm skipping over these 2 other arguments, where to start and how many to change. And now, that's going to say, I don't care about the case when we're finding it. Find it in a case insensitive way, and then go ahead and put in whatever I've told it to put in. So that's kind of nice to be able to say, make this case insensitive. Do that there. Is there a question here?
I don't not, but don't want to have to reprint all the names, the ones that don't include Dave. Say if that column is Dave.
Oh, yeah, so here's the question. So how hard would it be to make it so that we're not actually putting out this new name unless there actually is a name to change here? Here's the way that comes to mind quickest to do this probably isn't what you had in mind, but let's take a look at how I would do this. I would just say if my new name is different from the name that I'm currently looking at, then there's a difference. That's when I want to print it. In fact, then I could then print that and put my end if right here. But this actually brings up another form of the if function, the if statement that we didn't talk about. So what we're seeing here is the block if. The idea behind a block if is you can have as many statements as you want between the if and the end if. They will only be executed when the condition here is true, when the new name that I've calculated is different from the name that we were looking at. But if I only want to do it, and this will work just fine. But there's a special case of the if statement that says if you only want one statement to execute conditionally, you don't need the end if. Get rid of the end if and bring the statement up onto the same line with the then. Normally, nothing can go after the then. But now I can say just put one statement can go after the then, and this works as a single line. Some people absolutely hate this construct. They say, wow, why do that? Like does it actually save space in your code? Yeah, I would save like a few bytes of my code because I don't have to have the enter character, I don't need the end if, but that's insignificant. The only time that this is really kind of a valid thing to do is when you say, listen, I've got kind of this whole parallel structure. I'm looking at 20 different things. If this condition is true, make this change. And they're all really similar to each other. And if I can line them up that way, it's a lot easier to see the kind of the pattern in the code. But typically for a single line like this, it's up to the programmer. But I see it most often written still using the block if. But this will work as well. Now, we haven't done anything to clear this out, so let me go ahead and clear column E by hand. And we'll execute this again. And now we should only see, did I hit it? We should only see that show up where they're different. So David Cottrell is Dave Cottrell. Morgan Davidson is Morgan Davidson. Does that satisfy the question that you had, or did you want to see something different?
There a way to say if that cell if
Sure. Yeah, so if this has Dave in it, let's do this. So if in string, starting at the first character, looking at my string, looking for Dave, or looking for David, if that is, now, this is, in string is going to return the position where it found it, or if it doesn't find it, it returns 0, so I just ask if that is greater than 0. If it's greater than 0, it found it. I'll go ahead and clear off column E again. Execute this code. And behaves exactly the same. I'm going to go ahead and put this back into block if, because I prefer to see it that way, and it shows it the whole thing on the screen. So we've talked about several string functions. There are a few more. Let's suppose we wanted to make a print off a certain number of a particular character. We want to print off a bunch of underscores. And the number of underscores we want to print off is determined by some variable. We've got some variable. Let's go ahead and set this up here. I'm going to say x equals 17. I want to print 17 underscores. Put a colon here so I can do 2 lines at once. I can have 2 statements on one line if I separate them by a colon. Then I'm going to print, there's a function called space, S-P-A-C-E, I think. Space X. Oh, hey, that's like some rocket company, isn't it? That will print 17 spaces. It's kind of hard to see because they're invisible. But how could I change those 17 spaces into 17 underscores? Replace, look at the results of that function, look for a space, replace it with an underscore. And that then prints 17 of that character. So there's this function called space, which will just print however many spaces you want to print based on that. The whole idea, the reason that we even have a function like that is because we used to like print things out on paper with fixed width type. We almost never do this anymore. And so, we would print someone's name, and then we would have to fill in a bunch of spaces to be able to get the next column to start off in the right place. And so it was really common to say we had to print a certain number of spaces that we calculate as the width of the column, 40 characters, minus the width of the length of that person's name. That tells us how many more spaces we want to do. That's the reason that space is the character it generates here, instead of having it be a second argument with a character that you actually want it to be. It's because that used to be a really, really common thing. But that's another function. Go ahead. So, in this, we'd like to auto-fit all these names. Sure, at the end, we'll just come in here, and I will say s dot range, and then in quotes, I'll tell it I want columns C through E. What's the range notation for column C through E? Yeah, C colon E. Dot auto-fit. Now that is the whole column. But I'm not sure if I have to actually force it to be a column. We may have to do one more thing in here. Let's run this and see if it works. Yeah, so it doesn't quite like that. So I'm going to say take that and push it to the whole column. So there's an entire column. Dot auto-fit. The reference really was the whole column, but it's just that Excel didn't realize that was a whole column reference. And oh, this should be outside the loop. Yeah, it's auto-fitting after everyone, so it'll eventually get there. It'll just take a little while to get there. The book talks about a lot of mathematical functions as well, which you don't use nearly so much, like the modulus. Well, modulus is an operator, like square root and others. I haven't looked at the chapter for a while, but functions on math work similar to functions on strings. Questions here? That's built-in functions. Next time we get together, we'll make our own functions. Stay tuned. Oh, don't stay tuned. Come back. See you next week or next Wednesday, whatever that is. Class dismissed.